I'll try to make this short because I'm getting that same Spilkus feeling that I was talking about before. I think I've spent enough ink and paper going through the algebras of these models now that I'm still wondering whether or not we're thinking about these problems the right way. So I want to briefly ask each one of you a question and maybe even come back to Stephen and clarify something that Stephen and I disagreed about. First, Xiaojun, I don't understand the motivation that you gave with respect to the finite horizon problem. This idea of somehow if you've got noisier information on one dimension, somehow or another you inherently make yourself better off by choosing a horizon that goes with your most precise information. So if you could elaborate when I'm done on this, I would appreciate that. And as to a second point you made when you were talking about the OJ model and the ability to separate conservatism versus sort of the informativeness of the permanent earnings. One of the things that does is it sort of crystallizes in people's mind what two potential effects could be. But this model does not create a theory of why, for example, conservatism and the ability of smoothing might be correlated, and in what fashion they would be correlated, and how we would use that information. And so what keeps happening is I keep hearing people tell me why something is really, really important to consider. In this case, you said the accounting is very, very important, and I'm missing the theoretical part of what the accounting is doing to people's minds and what they're choosing. So if you could comment that, I'd appreciate it. Jim, I appreciate your point about the dimensionality being sort of an inherent criterion that I can look at and say something is better than another. But once I toss Z into the model, I have sort of I've restricted my world. And so I'm working within more dimensions than, say, the free cash flow model. But once I've made other assumptions about that model, it's like I'm pretending that somehow there's not a model that has more dimensions that would do even more. And so if you could comment on that. And then one last point about your discussion. You had a slide up there that said you wanted to compare the models empirically. And you started with the idea that somehow or another this model might be better if it predicts an analyst forecast revision. And I'm sort of confused about that because I didn't think we were testing the value of models in the sense that if algebraically they are the same thing. What I'm trying to test is whether or not a particular model does a better job of describing something that's going on in the world. And so, again, it's this sort of disconnect I sometimes get between our theories about how accounting affects our thinking or what we miss or what we get. And I'm not so sure what the sort of the importance of that slide. And if you could go on, I'd appreciate it. Peter, one last point. When you started discussing the model, you kept talking about empirical specification and whether or not these models are properly specified. And again, it sounds like I'm coming right back to the world where I'm saying, if you set up a model a particular way and you have no theory for how the world is supposed to work, and then you just run these models in their very basic forms, you can say that you've got a better specification in some sense, but we have no idea what it is that's causing the misspecification. And in some sense, we're taking very representational models. You mentioned the Barth, Beaverhand, whatever else were on the paper, where they were just taking a very simple representation and then trying to do an empirical test to see whether that information dynamic made any sense. And so are we thinking incorrectly when we talk about running horse races between the specification of these models? And should we be thinking more about the theories and how well these models help us say something? Which is, to Stephen's point, when I said the good thing about these models is the accounting doesn't matter, which means we have lots of degrees of freedom to use these models to think about theories. But I somehow get the sense from almost every one of your talks that we've inverted the process here. Sorry for taking so much time.
Yeah, I think I can still remember my question. Just to refresh your memory, I think the two questions for me. The first one is kind of elaborate what I mean as a motivation for this finite horizon and why it's needed. What I had in mind is pretty simple in the sense that you do a forecast that before you determine that you do a forecast, you got to have determined sort of that you know something better than the others. Otherwise, why waste your time? The other second component, you believe that somebody else knows better than you do something. So what I have in mind is, for instance, if you build something in the forecast and one of the components in this, say, future earnings, you know better, not the others, and you go 1 year, this factor may dominate, you do better. But if you go forward, for instance, a forecast, say, on Intel, I know the demand, but I don't know the cost. And 1 year ahead is sort of okay. If I build on this 1 year earnings, and then I forecast dividend based on that one, I forecast kind of what the book value is going to be, and then you build on the second year. Kind of whatever the arrow that you have there impounded in the first year is going to keep impounding. And at some point that you're saying, forget it, 10 years down the road, that the arrow that I have in infusing this model will outweigh sort of what I think I believe. So that is kind of, you can go 1 year ahead and maybe reverse engineering and say, suppose you believe the 1 year ahead earnings that you have a better shot than the other one. And then you reverse engineer the other one and say, what's the average PE ratio? And then use that PE ratio to apply for the when you do the valuation. That's all I have in mind. Jeff, you want to? Is that okay? Yeah. Okay. All right. Now move to the second one. It's the smoothing and the conservatism. That's my interpretation of the model. You separate them. One component that you assume the abnormal earning keep growing forever. I think it's more, this is what Jim said in the paper, is more suitable to capture the conservative aspect of the growth. And the other part, which is the earnings 1 year, you capitalize it, that captures the true growth in some sense, together with the conservatism. Now, of course, I agree with you 100%. We don't have a theory why that is the case. Those are, I believe, it's sort of assumption in the sense that you believe 1 year ahead earnings can reflect the earnings power, and then you also believe there is the other accounting conservatism can create some noise, and then if you compare by comparing 2 years ahead earning and 1 year ahead earning, you can tease out that components and apply a different valuation multiple. I think that's it. I don't think there is some kind of theory why that is the case. I mean, it's more of, I think there's certain aspect that, for instance, when we do accounting, we tend to do smoothing, but we cannot, because of the reliability constraint, we cannot go too far ahead. We kind of tend to smooth maybe 3 years down the road earning, but beyond that, maybe beyond one transaction cycle, we are limited. So I think that captures kind of what's the implication of those, but that's just what I think. All right? Yeah. Okay.
I'm actually tempted to ask the questions you asked the previous speaker. You asked me two questions. One is the nature of dimensionality, and the second thing in terms of how you evaluate an evaluation model. So let me speak to the first question first, of course. The basic idea here is that simplicity is an enormous virtue in our line of work. And once you buy into that, you're going to have the usual trade-offs. Everything else constant, I like the model as simple as possible. If I want to add another dimension, and of course we want to add another dimension if for no other reason it keeps us busy, so to speak, and it's nice to have a deeper understanding. But if you do that, then you have to keep in mind two things. First of all, you have to go beyond sort of the pure mathematical mechanics. And you sort of have to ask the question, what is this fourth dimension going to be all about? In other words, you can't just sort of make ZT a vector or something like that. And that was actually part of the message. In other words, when you go from a permanent earnings model to the growth model, you have to keep in mind that it's not a matter of just doing a little bit more math, a little bit more general math. It's a matter of capturing the concepts. So that's sort of how I think about it. In other words, what's the model that comes after the permanent earnings model, and without being quote-unquote mechanical. So that's sort of my answer to your first question. And another way, my short answer is I hate math. It's a necessary evil. So everything else constant, I really try to keep my math as simple as possible. With respect to your second question, I mean, it's sort of a more tricky matter because it's partially a matter of taste. But I think it's a useful way of thinking about valuation model that you can tell when the input is in error. In other words, suppose I calculate an intrinsic price or whatever have you. I mean, I check up the actual price. If I have a really good valuation model and I believe the market is efficient, I will be able to hypothesize that my input is wrong. And then what I want to do is to test that. So if the company looks very cheap because, of course, the earnings estimates are very optimistic, I want to be able, if you have a good model, you should be able to validate, okay, your input is wrong, let's see. And so we wait a few weeks or longer if we have to, and we check up. The earnings are going to be revised downward. So I find that sort of kind of a helpful way of thinking about it, and I also believe it to be quite practical. Lurking in the background, of course, is that we don't want to think about valuation models as games against nature. In the stock market, you play against other people who go through their calculations. And somewhere along the line, it's important that you're not trying to find out what the intrinsic value is. It's sort of a construct. What you're really trying to find out, if I want to go long in this stock, then how does my thinking differ from the rest of the folks? So that's part and parcel of the overall package. So if I believe a market is efficient, which is presumably a very good, useful first-order approximation, and I find out that the stock looks cheap or expensive relative to the actual observed price, then I should be able to validate that there are errors in the input, i.e. there are errors in the expected earnings and the growth in expected earnings. So that's sort of my answer. I find it a very nice way of thinking about the useful valuation model.
I think the question was, if I remember, Jeff, that it was addressed towards the reverse engineering approach to inferring from price data, model structure, and I think you used the term, there's no theory of the way the world is supposed to work. I think there are a set of properties, both accounting and economic, that we should use as a starting point. So no arbitrage is one, as I mentioned. I think there are accounting properties like clean surplus relation, which can help constrain the shape and structure of the model. But there are other assumptions which typically are being made in the model building exercise, which are forecasting assumptions, which may not be descriptively valid, and yet may be critical to the inputs that would be predicted to be relevant in valuation. So I guess what I'm arguing for is a sort of inductive approach to theory building where we use what we know from empirical analysis on value relevance to inform the inputs to the model, and then to figure out what role these inputs play in the forecasting process, ultimately the forecasting of the future cash flows or dividends or permanent earnings, whichever way you want to look at it. To be relevant in valuation, I think it's pretty well understood that a variable should play an independent role in forecasting, and the best way to figure out likely candidates for inputs into higher dimension models where we perhaps want to drill down into the income statement or the balance sheet and think about the possibility that the bottom line numbers aren't fully informative, that components matter, then the best way of identifying the components we'd wish to build into models that are going to be of practical use, the clues as to which those variables should be could come from the value relevance research. Then build in to the forecasting model that we're sort of engineering out of prices some structure that makes sense with reference to the economic model properties and the accounting properties. And this could extend down to knowledge of how we know accounting works, what roles accruals play in smoothing, for example, and how that should affect the serial cross-correlation between cash flows and accruals, which could be built into an information dynamics structure.
Other questions? There are no more questions left. Thank you very much. Please join me in thanking our panel.